Hi everyone, this is 4.7 part 2. The title of the section is absolute value functions, and even though we're using absolute value for the graph, our main topic for this section is really transformations. And as a quick review from part 1, to transform means to change, and what we're doing is we're taking a look at how a change in an equation changes the graph. And in part 1 we talked about 1, the shift, or the translation. We're going to learn 2 more transformations today. And the first one is a reflection. Now, a reflection is exactly what it sounds like. It's like a mirror image. So if you take your graph and you flip it, or you take a mirror image of your graph, that's what we call a reflection. Now, reflections happen when you multiply by a negative number. So remember, from part 1, our translations happen when you add a number. And it can be plus or minus. Adding and subtracting is basically the same thing. And we said if you add a number outside the absolute value, it moves up or down. And if you add a number inside the absolute value, it moves left or right. Well, we have kind of the same relationship here, whether it's all about where you're multiplying by the negative. So if I take my absolute value function, absolute value of x, and I multiply it by a negative, what it does is it does an up and down or a vertical reflection over the x-axis, and it takes that V shape and it flips it upside down. So it's an upside down V shape. So for our first example today, let's just graph f of x equals negative x, negative absolute value of x. All right, so I'm going to draw myself a blank graph here. And I'm going to do the same thing I did in part 1. Let's start by just drawing absolute value of x, which is, remember, this is the thing we learned from this section. It's that perfect V-shaped graph like that. Now, if I ask you to graph negative absolute value of x, I said we're going to take that graph, we're going to multiply it by a negative. In this case, it's like a negative 1. All it does is it takes it and it flips it upside down. What's actually happening here is you are turning the x-axis into a mirror. And you're doing the mirror image of the blue graph on the other side of that line. So what it'll end up looking like is this. You'll have the exact same graph, but upside down. So right there in blue is absolute value of x. We just learned that graph in part 1. And in red is negative absolute value of x. If you take the absolute value of x, or the absolute value function, and you multiply it by a negative, it flips it upside down. It turns the x-axis into a mirror and flips it upside down. Okay, now remember I talked about the relationship for translations. When you do something outside the function, it's up and down, and when you do something inside the function, it's left and right. Well, we have the same relationship here too. If you multiply what is inside the absolute value function by a negative, then it reflects it sideways instead of up and down. Now, for an absolute value graph, that actually doesn't change it. And this is why. Let's take a look at absolute value of x again. But what I'm going to do for this one, just to make it easier to talk about, I'm going to use 2 different colors. So I have this part, I'll draw it in green, and this part, we'll draw in purple. So let's say that's absolute value of x. Don't worry about the colors, I'm just going to use it so I can talk about it real quick. If I was graphing absolute value of negative x, what I would do is I would flip it sideways. So this time I'm going to make the y-axis the mirror, and I'm going to flip one side to the other. Well, you can see what happens if I do that. The green part flips over and turns into the purple part. The purple part flips over and turns into the green part, but it ends up the exact same graph. They just switch spots. So if you take the colors out of the picture and just draw the graph, this graph right here is both absolute value of x and absolute value of negative x. It's the same graph, because when you do that reflection, it takes the 2 parts of your V and it just flips them, but it still ends up being the exact same graph. But the reason we're learning these transformations, remember, these are universal. This works for every graph. So this is a rule. Multiplying by a negative inside your function is going to be a sideways reflection. It's going to take everything from one side and flip it to the other, and everything from the second side and flip it to the first. So those are our two reflections. It's all about multiplying by a negative. If you take the absolute value and multiply by a negative number outside of it, it flips everything from the top to the bottom. It would also flip from the bottom to the top, but there's nothing on the bottom for an absolute value. So when you do the reflections, it's both ways, top to bottom or bottom to top. And then this one on the screen right now. When you multiply by a negative inside the function, it flips from left to right. All right, so that's two transformations. The last one is called a dilation, or what I like to call a stretch. And to me, this is probably the hardest transformation because it's what we call a non-rigid transformation. It actually changes the shape of the graph. The translation's easy because it just moves, but it stays the same. The reflection, that's medium. It flips, but it still stays the exact same shape. This is going to change the shape. So you're going to start with a V. You might end up with a really skinny V. You might end up with a wider one. It's still going to be basically V-shaped, but it's not going to be exactly the same anymore. Now, this comes from multiplying by a number. By taking your function and multiplying it by 2 or 3 or 10 or 1/2 or something like that. When you do that, it stretches the graph or it dilates the graph and it makes it taller. Oops, I went out of order, that's okay. For the absolute value graph though, I want you to realize what it does. If you make a V shape taller, the way it's going to appear to you is skinnier. So the bigger the number that you multiply, the skinnier it gets. And I'll show you why when we do our example today. Now for this one, what I said is it doesn't matter if you multiply inside or outside the function. It's actually going to do the same thing. It's going to take it and it's going to make it skinnier. So let's take a look at an example. Let's graph g of x equals 3 times absolute value of x. Now for this one, because I want to show you how the stretch works, I'm going to be a little bit more careful on my graph, and I'm going to actually mark some points. I'm going to count off some points. All right, and I'll start off by drawing just regular absolute value of x, which is that V shape. Oops. Absolute value of x, there we go. Now, here's how the stretch works. We're going to stretch it and make it taller. And a good way to see what's happening is to just pick one point on the graph. Like let's say I pick this point right here, which is the point 2, 2. What we're going to do is we're going to make the graph 3 times as tall, meaning we want to make the height of that point, how far you're going up from the x-axis, 3 times as high. So right now, that point is up 2. If I'm multiplying, stretching times 3, I'm just going to take the height of the point and multiply it by 3. And 2 times 3 is 6. So basically what I'm going to do, instead of the point 2, 2, I'm going to go up here, 1, 2, 3, 4, 5, 6. I'm going to go up here, and I'm going to mark the point 2, 6. See, that point is 3 times as high. I just picked one point randomly. I could have picked any point on the graph. I picked the point 2, 2, and I said I want to make it 3 times as high. So I took the y value, 2. Instead of going up 2 squares, I went up 6 squares. 2 times 3 is 6. Now what you're doing, remember the graph is still V-shaped, so what you want to do is start from the same place, 0, 0, and go through that point instead. So you can see how I said it's actually getting skinnier when it gets taller. And the graph is always exactly the same on both sides, so just draw the same shape on the other side. And that red graph right there is 3 times the absolute value of x. So you can see when I stretch the graph taller, here's my original V shape. When I stretch the graph taller, what it actually does is it makes it look skinnier. And the bigger the number is, the skinnier it's going to get. If I had you graph 10 times absolute value, it would be very skinny. Or 20 times absolute value, very, very, very skinny. The other thing is, if I multiply by a number less than 1, like a fraction, if I multiply by 1/2 or 1/3 or 1/10, then it actually gets wider. And you get a shape where, in fact, I'll draw one in here for you. If I wanted to graph like 1/2 x, 1/2 absolute value of x, you would end up with a graph that looks more like this. And this isn't part of our example, but just to show you, this would be like 1/2 absolute value of x. You would have a graph that's flatter, wider V shape. So the bigger the number, the skinnier it gets. The smaller the number, the wider it gets. And we're going to combine it all together because we just learned that if that number is negative, it's also going to flip it upside down. So the next step, now that we've learned all 3 transformations, the next step is what happens if you have more than 1 in one problem. So for our last example today, I'm going to do the same thing I did in part 1. Instead of graphing it, I'm going to ask you to describe the transformations. And remember, that means in words. So let's do that. Let's describe the transformations here. So I'm going to say number 1, let's start with the graph of absolute value of x. Remember, if you're going to do transformations, you have to have something to transform or something to change. So I always state what I'm starting with. I'm starting with that regular V shape. Now, what I see when I look at this is actually 3 transformations. I'll color code them to match with my answer. Number 1, right here, that negative, that's a reflection. So when I multiply by a negative, now remember that's outside the absolute value, that's the one that flips it upside down, goes from top to bottom. So the first transformation, I'm going to say I'm going to reflect the graph. Now there's a lot of ways to word this. You can say vertically, you can say up and down, you can say over the x-axis. That's another good way to do it. In fact, I think that's how I'm going to say it. I'm going to say reflect the graph over the x-axis or across the x-axis. That's basically saying the x-axis is going to be the mirror, and you're going to flip anything from the top to the bottom and anything from the bottom to the top. Okay, now transformation number 2, I'm also multiplying by 2. See, I'm actually taking my absolute value function, the 2 absolute values, and I'm multiplying by -2, but I want to separate that. I want to say I'm multiplying by negative, that does the reflection. Then I'm multiplying by 2, that does a stretch. So even though it's one number, -2, it's actually 2 transformations. And that's transformation number 2. I'm going to say I'm going to stretch the graph, and I'll just say times 2. You could say 2 times the height, 2 times as tall, however you want to word it, but I'm going to stretch the graph times 2. Now we have one more transformation here. It's this -4, and that was from part 1. We're adding a number, it's negative, but we're adding a negative or subtracting. It's inside the absolute value, that goes left and right. And then remember, we talked in part 1, that's the one that's kind of backwards. Like you see the -4 and think maybe it goes 4 to the left, but it's actually 4 to the right. So for the last transformation, we are going to shift the graph 4 spaces to the right. So what I did, and you can see with each arrow where I got the information from. I said I'm going to start with absolute value of x. Because there's a negative out front of it, I'm going to reflect it. Because there's a 2 out in front of it that I'm multiplying by, I'm going to stretch it. And because there's a -4 inside the absolute value, I'm going to shift it 4 spots to the right. Now, if you needed to graph it, you could do it. You have everything you need. But remember, I'm just kind of mixing it up. Sometimes I have you draw the graph. Sometimes I have you guys describe the steps to draw the graph. And you can see what I meant by this is all the transformations mixed together. We had a reflection in there, we had a stretch in there, and we had a shift in there. Those are the 3 transformations you learned, and you might see any or all of them in any of these problems.